Are you ready for your geometry test over area and perimeter? We're about to find out. So we're going to go through our review, and the first page is pretty simple because the beginning part 1, tells us to write the formula for the area of each figure. All of these should be in your class notes. So an area of a circle is pi times r, which is the radius squared. Area of a trapezoid, we take our bases, base 1 and base 2, and we add those together. So we do base 1 plus base, I'll get this right, 2, times the height divided by 2, and the height is always going to run perpendicular between the bases, which means at a 90-degree angle. Now the triangle, we do base times height divided by 2, and the base and the height have to meet at a 90-degree angle. The regular polygon, which is any polygon with all sides equal to one another, it doesn't have to be a pentagon as shown. The formula is the little a times perimeter divided by 2. Now the little a stands for apothem or apothegm. I like to say apothegm because I think it sounds more fun, but you can say it however you want. And the apothegm begins at the center of the shape. If the shape was inscribed in a circle, then it would be from the center of that circle to the midpoint of any side would give you the length of the apothegm at a 90-degree angle there. For number 5, we're doing a rectangle. Formula for area of a rectangle is base times height, or you could think of that as length times width, same thing. Number 6 is a kite, so we can take diagonal 1 times diagonal 2 divided by 2 and get the area for that shape. Now the sector, the way that I usually show my students is I take the area of the sector over the degrees for that sector, which would be measured from the central angle. And sometimes we use the fancy Greek letter theta to represent that. Is going to be equal to pi r squared over 360. So that sets up a proportion which you can then cross multiply and solve for a. If you do get the a by itself, then that means you're multiplying the degrees times the area of the circle, pi r squared, and dividing by 360 to get the area of that sector. Sorry for the messy handwriting. I need to get a better stylus, or maybe just more practice. And then last we have our parallelogram, which the formula is the same as a rectangle, base times height, but it's a little different because the base will be on the bottom, but the height has to be measured at a 90-degree angle between the bases. Okay, now the next part is just vocabulary words. Again, you should have this in your class notes. AB, the segment AB on number 9 is the, again, apothegm or apothem of that shape. XY is an altitude. Some of you like to call that the height. Altitude is the better geometry word, but they are synonyms. Number 11, PQ is a radius, and radius is a word we normally think of as being on a circle, but when we're finding areas of regular polygons, it's helpful if we think about that polygon being inscribed in a circle. So it's technically the radius of the circle that goes around it. Number 12 is a regular polygon, is what we're looking for here, because that's the name of the shape that we've been finding the area of. Probably a more descriptive word would be a pentagon, but we're just using a regular polygon in this unit to describe any number of sides Number 13, the shaded area of figure 2 is called a sector. Looks like a pizza pie slice. Okay, going on to number 14. This shaded region is called a segment of a circle. If you'll remember, that's if you had the sector and you didn't shade in the triangle part where you connect each radius of that circle. And the last one here looks like a donut or a tire or a ring, but it is called an annulus. Or for plural, that would be annuli. Number 16. On part 3 here, we are finding the area and the perimeter of each of the following figures. We are to give answers to the nearest tenth, which means we're going to leave one number after each decimal, if there are any. And we're going to use appropriate units. So that means whatever units are given in the problem, we will just use them as is for perimeter, but for area, those units will be squared. So the first one, perimeter, is really easy because the two sides, the left and the right side, are marked congruent, so they're the same. So we have 10 on each side. So I add 10 plus 12 plus 10 plus 28 to get a total of 60 centimeters. You're definitely going to want to use a calculator for some of the calculations we're going to be doing, rounding answers to the nearest tenth. Area. For the area of this shape, it's a trapezoid. We're going to take the base 1, which is 12, add it to the base 2, which is 28. Then we have to multiply that by the height, which we don't know, and divide by 2. So our next job is to find the height. And a lot of these problems are multi-step. You have to find one measurement before you can find the measurement you actually need. So we're going to split this into two congruent right triangles and a rectangle in the middle, which means this bottom section will be the same as the top base, 12. And if I take 28 minus 12, I'm going to have 16. So 16 is what's left on the left triangle and the right triangle. If I divide 16 by 2, that gives me 8 here and here. Now, some of you might remember from when we were studying Pythagorean theorem, the Pythagorean triple, 6, 8, 10. If you do, then you are a step ahead because you already know that the altitude of this trapezoid is 6. But let's say you didn't remember that pattern. Then you would do a squared plus 8 squared equals 10 squared, and solve for a to get that a equals 6. So if I take 12 plus 28, then multiply that total by 6 and divide by 2, I get a total area of 120 centimeters squared. All right, number 17. We're going to need we know the bottom is the same as the top, 6 inches on the top, 6 inches on the bottom. But we're going to need the measurement for the left and the right side of this rectangle in order to find both the perimeter and the area. Now, the fact that this 30-degree angle here is a hint that this is a 30, 60, 90 right triangle. And we are given the short leg of that, which is 6, which means the long leg, the one that is the side, is going to be 6 square roots of 3. And that is from our special right triangles that we learned about earlier this year. Now we can find the perimeter by adding in our calculator 6 square root of 3 plus 6 inches plus 6 square root of 3 plus 6 inches. And when we add up all 4 of those sides, we get 32.8 inches. And that is just rounded to the nearest tenth. Last, we're going to do the area. The area is base times height, so I'm going to do 6 square root of 3 times 6 in the calculator, and that will give me 31.2 inches squared. Alright, the next page, number 18, we have a regular polygon. This one is a pentagon, so it has 5 sides. It shows us one side is marked 29. Since it is regular, all the sides are the same, so I'm going to do 29 times 5 in order to find the perimeter. That will give me 145 centimeters. That takes me all the way around the pentagon. Now, the formula for the area of any regular polygon is little a times capital P, which is for perimeter, divided by 2. They give me the little a is 11.3 here, times the perimeter, which we got was 145, and then divide by 2. So if I type that into the calculator, the result that I get rounded to the nearest tenth is 819 and 0.3 centimeters squared. Okay, number 19. Since we have the tick marks on the left and right side of this triangle, we know that we have a 16 centimeter side over here on the right. If I add 16 plus 16 plus 6, that gives me a total of 38. If I can draw an 8, those seem to be the hardest with the stylus. 38 centimeters is going to be the perimeter. Now, to find the area of a triangle is base times height divided by 2. I don't know what the height of my triangle is, so I'm going to have to figure that out. Now, when I split this isosceles triangle into 2 congruent triangles, that's going to mean that this base here of the half triangle is 3. So I can use Pythagorean theorem, 3 squared plus whatever my height is squared equals 16 squared, and I solve to find the height. So that's going to mean 9 plus h squared equals 256. Subtract 9 from both sides, so h squared equals 247. And then I take the square root on both sides to get that the height is equal to 15.7. So when I take my height of 15.7 and I multiply it by my whole base is the 6, 15.7 times 6 divided by 2 gives me the area of that triangle, which comes out to 23.6 centimeters squared. Okay, number 20. First thing we need to do here is find the perimeter. So we're going to go all the way around the shape and figure out how long all the sides are. So starting here at the bottom we have an 8. Then on the left side we're going to have the same as the right side. So that's going to be 32. The top is 32, the right is 32. Now down here at the bottom on this other little branch of this irregularly shaped compound figure, I don't have a measurement. So what I have to do is subtract. I know that all the way along the top is 32. And if I go in on the bottom, I go in 8, then 8 again, and finally 8 again. So that's 8 plus 8 plus 8, which will give me 24. And if I take 32 minus 24, that's going to leave 8 left for this bottom edge also. Now, coming up along this side, I have to figure out how long that one is also. So I notice that this whole side here is 32. And if I take the 32 minus the 16 here and the 8 here, that leaves me with 21 on this edge. So now I've got an 8 here, and an 8 here, and an 8 here, and a 16 here, and I've got a number on every edge of my shape. So I can go through and add those each up one at a time, and that will give me a total of 176 inches. Now, let me see if I can erase this so that we can work on the area a little bit. It's kind of messy and I can't read my numbers anymore. Okay, so to find the total area, what I'm going to do is I'm going to take the big outer square, 32 by 32, and find that total area. So that's going to be 32 times 32, and I'm going to subtract from that the area of the cutout pieces. So I've got this whole total area figured out. And now I'm going to cut out some pieces. I'm going to cut out this little square here, which is 8 by 8. So I'm going to subtract that away. And then I'm also going to cut out this little rectangle here, which is 16 high and 16 wide. So I'm going to subtract out 16 times 16. So if I do that in my calculator, I get an end result of 704 inches squared. Okay, number 21. I have a parallelogram. The left side and the right side are going to be the same as each other. So I've got a 7 on this side, and I can add 7 plus 12 plus 7 plus 12 to get the total perimeter, which is 38 feet. And now I need to find my area. Area of a parallelogram is base times height, but the height has to be at a 90 degree angle from the base. So since we have a 60-degree angle here, this is another one of those special right triangles, the 30, 60, 90. Now, we have the length of the hypotenuse being 7, which means the length of the short leg, which would be this side down here on the bottom, would be half of that, 3.5. And the long leg right over here, which is the height, which is what we need, will be the short leg, that 3.5 times the square root of 3. So that's my height. So to get the area, I am going to multiply the base, which is 12, times the height, which is 3.5 times the square root of 3. And when you type that in your calculator and round to the nearest tenth, one number after the decimal, you get 72.7 square feet. All right. Number 22. This shape is a kite. We have a property of kites that says that the diagonals bisect each other. So, oh no, not that they bisect each other, sorry. That this diagonal that goes between the congruent sides bisects the other one. So this is 3 here as well as on the top. To find the area, we are going to take diagonal 1 times diagonal 2 and divide by 2. So my first diagonal going across here is 10. That's 6 plus 4. And then my vertical diagonal would be 3 plus 3, so that's 6. So I take 10 times 6 divided by 2. So that's going to be 30 inches squared. Now, I'm going to erase to do the perimeter here. The kite has congruent sides that are consecutive. You might remember from your Pythagorean unit, that the Pythagorean theorem unit, that there was a Pythagorean triple, the 3, 4, 5 always made a right triangle. So that is the missing side here. If you did not remember that, that's okay. You can use Pythagorean theorem to calculate it by going 3 squared plus 4 squared equals c squared, because we're missing that hypotenuse, the side opposite the 90-degree angle. And of course 3 squared plus 4 squared is 25. And take the square root on both sides to get c by itself, and you get 5 is equal to c. So 5 is that side and the other one marked congruent to it on the kite. We also need to use Pythagorean theorem to find the missing length on the hypotenuse of the triangle right here. So we're going to say 3 squared plus 6 squared equals c squared. So that's going to be 45 equals c squared. Take the square root on both sides, and that gives us a c value of 6.7 when you round to the nearest tenth. So 6.7 here and 6.7 here. So if I add those four sides together, I get 23.4 inches for my total perimeter. Okay, here is another regular polygon. So this one is going to be similar to number 18. To find the perimeter, we know we have a side length of 10. There are a total of 6 sides on this regular polygon. So if I have 6 tens, that's going to be 60 inches for my total perimeter. Now, to find the area, I'm going to take the little a, which they have given me to be 5 square root of 3, multiply that times the perimeter, which is 60, we just figured that out, and divide by 2. You can do this in your calculator. You're going to need to round to the nearest tenth. That's going to give you 259.8 inches squared. Okay. Number 24. These say draw diagrams if necessary and show all of your work. Give answers to the nearest tenth and include appropriate units. So we're going to do for number 24 a trapezoid. The bases are 11 and 15 and the height is 9. So we're going to use the formula 11 plus 15, base 1 plus base 2, times the height, which is 9, divided by 2. And that gives us 117 centimeters squared. Number 25. Find the area of a rectangle with a base of 15 and a diagonal of 17. So, we're going to either remember that we have an 8, 15, 17 right triangle, or use Pythagorean theorem to find this missing side because we need it for the area that's going to be our height. So we do x squared plus 15 squared equals 17 squared, which is going to give us x squared equals 64, and take the square root on both sides, x equals 8. So the area is going to be base times height, that's 8 times 15, which gives me 120 inches squared. Alright, number 26. Find the area of an equilateral triangle, that means all sides are the same, with a perimeter of 90 feet. So I have 30 and 30, and if I'm going to do an area, I'm going to need a height, so I'm going to split this into 15 and 15. Now, if you'll remember, the angles of an equilateral triangle are all the same. Since they add up to 180, each of the angles is 60, which makes this half triangle a special triangle, a special 30, 60, 90 triangle. So I'm going to take the 15 and multiply it by the square root of 3 to get the height of that triangle. So I'm going to have base, which is 30, times the height, which is 15 square root of 3, divided by 2, and that's going to give me 389.7 square feet. Number 27. Find the area of a circle with a circumference of 14 pi. So circumference is 2 pi r. So I'm going to fill 14 pi in for the circumference. And getting r by itself, I'm going to divide both sides by 2 pi, which is going to give me that r equals 7. So if the radius is 7, I use area equals pi r squared to find the area of the circle. So that's going to be pi times 7 squared, which is 49 pi, which comes out to 153.9 millimeters squared when you use your calculator. Number 28, find the area of a square with a diagonal of 15. We need to know the side length. This is a 45-45 special right triangle. So I'm going to take 15 and divide it by the square root of 2 to get the length of the side. So the side length on the square is going to be 10.6. So if I multiply 10.6 times 10.6, I get 112.5 square yards for the area of the square. Okay. Number 29, I'm finding the area of the sector. So I'm going to say the area over the degrees, which is 60, equals pi times 10 squared, pi r squared, over 360. I'm going to cross multiply. So I have 360a equals 100 pi times 60. Divide by 360 on both sides. And I get that the area is 52.4 centimeters squared. Alright, 30. The area of the square is 14 times 14, and I'm going to subtract from that pi times the radius. The radius is half of 14, so that's 7. So pi times 7 squared. And if I type that in my calculator, I get 42.1 square feet. Now 31, I'm going to do half of the area formula to do the big half circle. So that's going to be pi times the big radius squared divided by 2, minus, I have two little half circles here. So 2 times pi times the little radius squared divided by 2. Now what is the big radius? The big radius is 12. So pi times 12 squared divided by 2 minus 2 times pi times the little radius is going to be 6 squared divided by 2. And yes, these 2's do cancel out. So you end up with, in your calculator, 113.1 inches squared. Alright, last one. Mr. Simmons wants to tar the roof of one of his factories. If a gallon of tar covers 50 square feet and the roof measures 70 feet by 110 feet, how many gallons of tar will Mr. Simmons need to buy? Well, 70 times 110 gives us a square footage of 7,700 square feet. That's not the answer to the problem, though. 1 gallon covers 50 square feet. So we're going to take our total square footage and divide it by 50 to see how many gallons we need, which comes out to 154 gallons. Okay, I hope this has helped you to feel like you're more prepared for your area and perimeter test. If you need extra help, come in for tutoring and talk to your teacher. Good luck on your test. Bye.